Textbooks, open to page 202. You did review numbers 1 through 10 and 15. Let's go and take a look at those answers together. And 1 through 6, really straightforward, just order of operations. Some things involving signed numbers and exponents. We're going to look at that again today just a little bit. But number 1, really straightforward. What did you get for your answer, Dylan? 14. Start with the multiplication, then add. Number 2, what did you get for your answer, Joshua?
23.
Again, start with the multiplication, then add. Number 3, what did you get for your answer, Lana? That is not correct, Adam.
Homework. I know I did.
Adam, number 3, what'd you get for your answer?
I don't have number 3.
Did you not?
You don't have number 3.
I did.
Dylan, what'd you get for number 3?
Negative 25.
Negative 25 is correct. Remember, we square the 5, not a negative 5. Number 4, what'd you get for your answer, Adam?
Negative 16.
Negative 16. Number 5, what did you get for your Adam, Joshua? What'd you get for your Adam, Joshua? What'd you get for your answer, Joshua?
Positive 25.
Positive 25. Because here you are squaring a negative 5. And number 6, what did you get for your answer, Lana?
Still can't find it.
Adam.
16.
Positive 16. Number 7. What do we get when we distribute? Lana, forget finding the homework. Just tell me what we get for our answer on number 7.
12a cubed b negative 6a squared b squared positive 3ab cubed.
Perfect. 12a cubed b negative 6a squared b squared positive 3ab cubed. Number 8. What did you get, Dylan?
7x cubed y positive 35x squared y squared negative 14xy cubed.
Good. 7x cubed y positive 35x squared y squared negative 14xy cubed. Number 9. What did you get, Joshua?
Positive 6x squared, positive 24x, negative 6.
Excellent. 6x squared positive 24x negative 6. Number 10. What did you get for your answer, Adam?
Negative 15x cubed, negative 12x, positive 21.
Good. Negative 15x cubed, negative 12x, positive 21. And then dropping down to number 15. What do we have to do to solve this, Lana?
Distribute.
Well, kind of. Number 15.
Distribution.
Double distribution, right. We're going to have to distribute 2 things. First, we'll distribute the,
2x.
then we'll distribute the,
Negative 5.
and since everything's in descending order for us already, just a simple shift over should take care of keeping things nicely, neatly lined up in the partial products. We'll add them together and we will get what? Final answer, Joshua.
2x to the 4th, negative 11x cubed, positive 23x squared, negative 44x, positive 16.
Good. 2x to the 4th, negative 11x cubed, positive 23x squared, negative 44x, positive 60. How many got all 11 problems correct in the homework? Went 11 for 11. All right. How many, anyone just missed one of the ones? One of them. All right. Any questions on the one or ones we missed? Any questions on the homework? Going once on homework. Going twice on homework. Go on, turn back to page 121. Turn back to page 121. Let's take a look at a couple of word problems together. And we'll start on word problem number 10 there on page 121. And any of you like to fish? Anyone here like to go fishing?
Yeah.
Spend a long time sitting by the water, drowning bait, catching nothing.
Kind of
Kind of
boring.
boring.
Yeah, it is kind of boring, I'll be honest. Though, that moment of excitement when you finally get the bite, you know, makes it all worth it. But yeah,
We had
overall,
it.
it's
One
pretty
time we
cool.
had it bite, but then it just
It
went
ran
away.
away.
It like got it
The
off
food.
and then went away.
Yeah,
Yeah.
kind of hate that. Yeah. Okay. Well, anyway, let's have Joshua read number 10 for us.
Aaron, Ross, and Patrick caught a total of 23 channel catfish. Aaron caught twice as many fish as Patrick, and Patrick caught 3 fewer than Ross. How many fish did each boy catch?
All right. So, how many unknowns do we have in this problem here, Dylan?
3.
And they are
Aaron, Ross, and Patrick.
Aaron, Ross, and Patrick. I'll just say Patty. All right. So, which of these gets to be X? Adam?
Patrick? Wait.
Why?
Yes, because it's all being like around him, like compared to like him or something.
What statement tells you Patrick should be the X?
Like twice as many fish as Patrick, and Patrick got 3 fewer than Ross.
Okay, initially it does sound like it could be Patrick. If you just look at that first statement, Aaron caught twice as many as Patrick, it sounds like it should be Patrick, but then it turns right around and says Patrick caught 3 fewer than Ross. which makes Ross, in my mind, your best bet for x. Now, you could solve it with Patty as your x, but probably Ross as your x. How should we represent Patty if he caught 3 fewer than Ross, class?
X negative 3.
X negative 3. And then back to Adam, since Aaron caught twice as many as Patrick, and we said Patrick is x minus 3, how do we represent Aaron?
2x minus 3?
2 times the quantity, x minus 3. Questions on this? Now, let's suppose, though, that we said, I really want Patrick to be x. Well, then, since Aaron caught twice as many as Patrick, class, Aaron would be 2x. But it said that Patrick caught 3 fewer than Ross. Well, if Patrick caught 3 fewer than Ross, then that means that Ross caught
X plus
3 more than Patrick, right? So you could have done it this way also. This is the most conventional approach, but this is not wrong. It's just you have to do some reverse thinking there, right? Like if I have $10 more than Lana, that means Lana has 10 fewer dollars than I have. So either I could be x and she could be x minus 10, or she could be x and I could be x plus 10. Right? It could go either way. That's kind of the idea. I like this approach best because I like the most straightforward, intuitive, the least thinking possible. Because I am lazy. So once we've got Aaron as twice Patrick, 2 times x minus 3, or class, we could have gone straight to the distributed form.
2x negative 6.
2x negative 6. That might even be quicker and easier for us, right? To go straight to the distributed form. We've got Ross as our x. We've got Patrick as x negative 3. The number we haven't used yet, class, is the number 23. And as they often do, not always do, but often do, the 23 is the total. So all we have to do is add them all together. Again, I would caution you, don't get stuck in the rut of assuming you always add stuff together, because you don't always, but we do because it says total. What should our equation be here, Lana?
4x negative 9 equals 23.
There we go. And again, the advantage of having it in the distributed form already, it just saves us a step later in the equation. Then to solve, class, 2 things. First, we will
Positive 9 plus 9.
Good, or just move the negative 9 over as a positive 9. Save yourself writing a positive 9 right here. I mean, I really am that lazy. Then move it over as a positive 9 to get 4x equals 32. And then, of course, we will do the division in our head to get x equals 8. Now, that's not a bad haul at all. Who caught 8 fish? Ross. How many did Patty catch?
5.
5. That's still not bad. And then Aaron,
5. I mean,
10.
4.
Twice as many as
4.
Patrick, right?
Maybe 4.
Twice 5 is 10. Or if you plug the 8, which is x, in right here, that's 16 minus 6 is
Maybe 4.
10.
Wait, 10?
16, remember x is 8. So not 2 times 5 minus 6, 2 times 8 minus 6.
She probably added.
Oh.
She probably added.
No, she pulled the 5 in for the x here. But again, the f5 is the x minus 3, not the x. The x is 8. Does that make sense? Also, remember it said Aaron caught twice as many as Patrick, so we need to make sure we double Patrick's number. Patrick was 5, double it to 10. And sure enough, there's your 23 catfish.
I wonder who that weird little kid in there is.
I don't know. He's only got 1 fish. It's not particularly huge, but it's not bad either.
He doesn't really look like he's in 9th grade.
I don't know. Well, it didn't say these were 9th graders, right? It just said they caught the catfish. All right, number 11. Go ahead and read this for us. Let's see. Any of you actually, well, guys, you don't want to put magnets and stuff in your locker to decorate, do you?
I do.
I do.
Really?
I'm
Okay,
cool.
all right.
just
I'm just boring, I guess. But Lana does. So Lana, read number 11 for us.
Vicky and Sarah have a total of 53 magnets on the inside. Wow.
Yeah, yeah.
I only have like 10. I only have like 10. Vicky has 4 fewer than twice as many magnets as Sarah. How many magnets does Vicky have on her locker?
At your seats, do number 11. At your seats, do numero 11.
My voice is terrible.
It's because your foot's on the seat in front of you. See, I'm a doctor. I can diagnose problems quickly and efficiently.
Yeah.
So your voice already sounds better.
You're already a pro at scaring kids.
Trust we all had two unknowns, Vicky and Sarah. We all had Sarah as x. How do we represent Vicky, anyone?
2x
2x
negative
negative
4.
2x negative 4. Trust we also have the equation 3x negative 4 is equal to 53.
Yeah.
Trust we brought the negative 4 over as a positive 4 to get 3x equals 57.
Oops. Yep.
And then divided by 3 to get x is equal to
19.
19. So who had 19 magnets?
Sarah.
Sarah. That's a lot of magnets, but it's not as many as Vicky.
She had 34.
34 magnets. I wonder where the rest of the locker was. Questions on this? Oh, and the only answer we're interested in is how many does Vicky have? So all we really care about is the 34. Always good to know which answer they are actually asking for. Questions on these word problems? Feel good to go? Still, word problems still pretty easy? Okay, try to keep it that way. Page 199 in your textbooks. Page 199 in your textbooks. I want you to do numbers 35 through 37. They're at the bottom of page 199. Numbers 35 through 37. They're on page 199. Practicing with some double distribution and then a cubed binomial.
$35 and 37?
35 through 37. Probably best done on paper. There's not a lot of room to work in the book. Oh, I copied it wrong.
Oh my word. I didn't even get to that. Wow. Wasn't there a shortcut to that one?
Yeah, I haven't taught it to you yet. It's coming in Algebra 2.
Didn't you say there's another one?
Well, if there's a fourth power, the shortcut was once you've multiplied two of them, or basically squared one of them, the other two will give you the exact same thing, and then just do a triple distribution as opposed to another double distribution and another double distribution.
Why did they put ones like that on there? It's annoying.
To help you to work on being faster and more efficient in your multiplication.
It's annoying though.
It is. And because they want heaven to seem so much sweeter, because you won't have to do this in heaven one day.
Yay.
The Bible says on this earth we will suffer persecution and tribulation, but in heaven all will be glory. The tribulation and persecution, math class. See how that works? Yes, sir.
You think they have violins and saxophones in heaven?
Violins and
They'll
saxophones.
have all instruments, I'm pretty
Oh,
sure.
sure, and then instruments we've never even heard of, I'm sure, because God loves music. Music was created by God for His worship and His glory. Obviously, the devil's messed it up. There's a whole lot of music that doesn't glorify God these days, but music is something that God is pleased with. In fact, Lucifer was the chief musician in heaven, and then he was cast out, so is it any wonder he corrupted music? That was his thing in heaven. All right, for sake of time, let's go ahead and put your pencils down and take a look here. Check your double distribution. Number 35, how many got this answer? 3x to the fourth positive 4x cubed. Plus 13x squared plus 4x. All right, on the next one, double distribution. And you see where I started to put my negative 35x squared. And as I started to write x squared, I'm like, wait a second. X cubed and x, oh, that's right. It's a 2-space gap. I need to shift over twice. Yeah, so you shift over twice, whatever. End up getting negative 21x to the fourth positive 18x cubed, negative 50x squared, positive 30x, negative 25. How many have this answer? For the second one, number 36. Questions on number 36. Number 37, we had to cube the x plus 3, which means 3 of them. Multiply the back 2 to get x squared plus 6x plus 9. Then double distribute the one that's still left. End up getting x cubed plus 9x squared plus 27x plus 27.
Plus 9x right there.
What?
The positive 9x, where'd you get that?
The positive 9x squared?
No, like up there. Like right here.
Right here?
Yeah.
Oh, when the x gets distributed to the 9. See, the x times the x squared is x cubed, x times 6x is 6x squared, x times 9 is 9x.
Oh.
Yeah, that was the x being distributed. And the next row is where I distribute the 3 to get all those numbers. All right, any other questions, comments? All right, turn back to page, or turn ahead to page 202. Turn ahead to page 202. Yesterday, we transitioned off of multiplication and started working on division. And we said to divide monomials class, we have 3 steps. What are they?
Sign, number, letter.
Sign, number, letter. With the sign, we said if the signs are the same, we get a
Positive.
If the signs are different, we get a
Negative.
negative. With the number, we said, well, just divide, unless you can't. I said if you can't divide, reduce. Because how do we write division problems? It's with fraction bars. So it's already going to be written like a fraction, so treat it like the fraction that it is and just reduce if you can't divide. If you can't even reduce, then don't worry about it. We said with the letters, to divide like basis class,
Or subtract.
subtract the exponents. When do we add the exponents, Lana?
Multiply.
We multiply like bases, right? You're on page 202. I'm not, but I'm about to be. And question number 1. Which operation is applied to the exponents when monomials are divided, class?
Subtraction.
Subtraction. Number 2. Which operation is applied to the exponents when monomials are multiplied? Addition. What operation is used to raise a power to a power? Multiplication. Do numbers 4 through 24, the even. Do numbers 4 through 24, the even. They're on page 202. Practicing with sign, number, a letter, such as we worked on yesterday. Okay, don't copy the problems down, just answer them in your heads. Yeah, be lazy. Too lazy to write these down. You ever look at the problem, write the answer, go to the next one. Look at the problem, write the answer. You might be able to write them right there in your textbook, since all you're doing is writing answers anyway.
Oh.
It's not like we have to work anything out. Unless, of course, you wanted to save your textbook in excellent, pristine condition and sell it on eBay and make $20 at the end of the year.
You can really make 20
I don't
bucks.
think anybody's gonna buy it.
Oh,
Yeah.
you
Unless you're on
may.
a backup.
And there's millions of people who are using Abeka around the world, yes. Hundreds of thousands here in the United States.
You could really sell it on
I
eBay.
sell a bunch of Abeka books
Oh,
every year.
I should have saved my life.
Yeah. And if it's in good condition, $20 for one of these books is a steal because they cost parents about $45 new.
Ooh.
So they would be glad to pay half price for a good condition used book.
Ah, I've already started writing.
I mentioned it at the beginning of the year, I just didn't give you all the details, I guess.
Unless they wanted, I could still sell it. It
You could go
only
through
has
it
a
on
few
plates.
answers.
You could do that, but you probably want to charge a little less, but It looks like Joshua's finished with the 4 through 24 even. Quickly working sign, number, letter on each of these. Stress relief. Something about fidget spinners.
Those are so old.
I know.
Poppets.
Poppet.
Why?
Do your kids have them?
No, I don't know what poppet is.
You don't?
There's these boring little things. that
They're
you-
like, you just push your rubber in and out pretty much.
Yeah.
It's so boring.
One side's loud and the other one's kind of soft.
It's like a whole bunch of bubbles. It's not even like bubble wrap because it's rubber.
Yeah.
It's pretty dumb.
You don't get the satisfaction of bubble wrap.
Some of them are satisfying, some of them are not.
And Lana, are you done?
No.
Okay, good. Dylan, are you finished? 14 through 24 even? Okay, let's take a look at our answers here together. Number 4. When you divided x to the 12th by x to the 8th, you got what, Adam? Number 4.
Did I get x to the 4th?
Hopefully. X to the 4th. Number 6. What did you get for your answer, Lana?
Negative 1/2 x to the 4th y.
Good. Negative 1/2 x to the 4th y. Or negative 1 x to the 4th y over 2. Or negative x to the 4th y over 2. And you could just don't bother writing the 1. Any of those answers would work. Number 8. What did you get? Joshua.
2x squared y squared.
2x squared y squared. Number 10.
Oh.
Dylan.
3x to the 5th y.
3x to the 5th y. Number 12. Adam.
Negative 4x cubed y squared.
Negative 4x cubed y squared. Number 14. Lana.
Negative 12k to the first.
Good, negative 12k to the
just
first,
negative.
or just negative 12k. Number 16, what did you get, Joshua?
Negative 6 over c squared.
Good, the a squareds cancel, the b to the 7ths cancel, and 3 of the c's cancel, but that leaves you with 2 c's in the denominator, so negative 6 over c squared. Great job. Number 18, what did you get, Dylan?
A squared over bc squared.
Good, the a squared is left in the top, and we have a b and a c squared left in the bottom, so a squared over bc squared. Number 20, what did you get, Adam?
4x over y.
4x over y. Number 22, Lana.
9a squared over b squared.
9a squared over b squared. Number 24, class.
1.
1. Because anything to the 0 power equals
1.
1. How about number 25? Go and do that in your head very quickly, Dylan.
X.
Oh, class.
One.
1.
What?
Just 1. Because it's to the 0 power. And anything to the 0 power just equals 1. Yes,
What
ma'am.
was number 8?
2x squared y squared.
Oh.
Because 10 divided by 5 is 2, x to the 4th divided by x squared is x squared, and then y squared divided by nothing, because there's, it has no friends, it's just y squared. All right? Did anyone get all of those correct? Anyone get all of them right?
All of them said.
Anyone just miss one? All right, any questions on the ones we missed?
Number 10, I forgot.
Forgot what?
Well, I forgot to do number 10.
Oh, you just forgot to do number 10, okay.
Yeah.
This is Adam disease, and he forgets to do them in the homework, you forget to do them. All right, look at number 23, if you would, very quickly. And this one's a little bit ghastly. We've got a 5y over a 2/3 y squared. And as far as the letter is concerned, the letter's not too bad. So let's skip the sign and number for a second and go straight to the letter, class.
Y.
In the denominator. We know we're going to get a y in the denominator. But as far as the number goes, this is called a complex fraction. Do we remember talking about these in junior high? A complex fraction, again, is a division problem. So this really means 5 divided by 2/3. But you might recall that could be written 5 over 1 divided by 2/3, right? But we never really divide fractions, class. We always multiply by the reciprocal. So let's make this a 5 over 1 times
3 twos.
3 twos, or 3 halves is the more appropriate way to say it, but I like 3 twos. And unless they're biting me, then I don't like them. And then we're going to multiply. And when we multiply, class, we get 15 halves. So I'm going to leave the 15 in the top and the 2 in the bottom. Does that make sense? Look at number 31. We've got a 1/2 x squared y cubed over the 4xy to the 4th. Let's start with the number. It shows a 1/2 divided by 4. But class, do we ever really divide with fractions?
No.
So I'm going to rewrite this as not 1/2 divided by 4, but 1/2 times
1/4.
1/4 to get
1/8.
1/8. Remember, you're multiplying, so the 2 times 4 is 8. And then let's take care of the letters. For my x's, class, I should get
X.
where? In the top. So I'm going to put an x up here with the 1. And for the y's, I should get
Y in the bottom.
y in the bottom. So I put a y next to the 8 in the denominator.
Did we do this last year a little bit?
Yeah.
We did talk about complex fractions last year. We didn't involve complex fractions within monomials or anything ghastly like that. We saved that for, senior high, not junior high. But yeah, does this make sense though on how we would handle it if there's a fraction in one of the terms? It's not, favorite obviously, because I hate fractions and I'm lazy, but we can handle it. Questions? All right, and then number 30 is kind of unusual as well. We've got an a to the 5x, m to the 2y, over a to the 3x, m to the 3y. And I told you the other day, algebra never changes. The steps we use are always consistent. And this fraction bar consistently means division. And we know that when we divide like bases, we're supposed to subtract the exponents. So when I subtract the exponents, I'm going to do the 5x divided by a to the 3x should give me
A to the 2x.
a to the 2x. By the way, in the top. Because these 3x a's cancel with 3x of these a's, so leaving with 2x a's in the top. So with the m's, I've got an m to the 2y divided by an m to the 3y.
M to the y.
M to the 1y where?
In the bottom.
In the bottom, because there were more m to the y's in the bottom. So we're going to leave an m to the y in the denominator. Does that make sense?
Mm-hmm.
What about this, though? Write this problem down, if you would. Negative 15 a to the m b c cubed over negative 10 a to the n b to the a c.
Oh.
This looks ghastly as well. It's a little bit more Algebra 2 level, but, want to preview it for you now, just, so in case you see something like this, end of the year on some kind of test or something, you know what you're getting into, or at least have an idea of what to do. It's still division of monomials, right? So we still have, what, 3 steps? Sign number little. Let's take care of the sign first.
Negative.
Positive, because the signs are the same. Now, as far as the number goes, can we divide 15 by 10?
No.
Not evenly. So let's reduce it down. Reduce each number by 5 to get
3
2s, or 3 halves. All right. Now, as far as the letters go, when we divide like bases, we subtract the exponents. Lana, when we divide like bases,
Subtract.
and when we multiply like bases,
Add.
you gotta keep those straight. All right, so here, I've got an a to the m divided by a to the n. I could write it this way, a to the m divided by a to the n, correct? And when I divide like bases, I subtract the exponents, m minus n.
Oh.
And there's my answer, a to the m minus n. And I have a polynomial exponent. Oh well, there we go. I think we saw one of those the other day, didn't we? Where we had to add the exponents together. We'll do the same thing here. With the b's, I have to divide like bases. And when I do, I have to subtract the exponents. Well, what is the exponent of the b? 1. So when I subtract the exponents, I'm going to get b to the
A minus
no,
1 minus a.
1 minus a.
Oh, right.
Because again, this is b to the first divided by b to the a. So it's going to be 1 minus a.
Wow.
And then I've got a c cubed being divided by a c,
C.
3 minus 1.
Oh wait.
which is
2.
2. So c squared.
Yeah.
That one's actually easy. Don't let that one throw you off, right? 3 c's cancel with a 1 c to give me 2 c's in the top. But yeah, even if the letters don't match, there we go. It's not pretty, but it's correct. Questions? I wanted to show that to you there. Now, I wanted you to consider something else, though, and something we did talk about last year in pre-algebra. We said just a minute ago, if we had an a squared divided by an a cubed, right, that I would say these 2 a's cancel with 2 of the 3 a's class to leave me with
A.
in the bottom. But I said, what would be left in the top?
A 1.
A 1. 0 a's, and anything to the 0 power is 1. So an understood 1, which we don't leave understood, we write it. But I also said, if we follow that model, we've got a squared divided by a cubed, which means it has to be a to the 2 minus 3, which is what?
Negative 1.
A to the negative 1. This means the same thing. Consider this for a moment. X cubed divided by x to the 7th. Now the conventional way to do this is say I got 3 x's here, I got 7 down there, 3 of them cancel to leave me with what?
X negative 4.
1 over x to the 4th. 3 cancel away, 3 cancel away, but I still have 4 in the bottom, right? But if I just went straight up and I said I'm just going to subtract the exponents, I would end up with x to the negative 4th. It's the same thing. Now, as a general rule, I despise negative exponents. Okay? I would rather not have them. So this is why I prefer these answers, which is why this is what I taught. But this is still correct, technically. This is still correct, technically. And so we notice that a to the negative first means 1 over a. Well, if I said 5, and I said 1 over 5, how are these related? They are reciprocals. A and 1 over a are reciprocals. X to the 4th and 1 over x to the 4th are reciprocals. This negative exponent then means reciprocal. Write that statement in your notes with a star next to it. Negative exponent means reciprocal. Joshua Lana, I know specifically we talked about this last year. Do you remember that now that we've referenced it? And then, Adam, I don't know if the other, because you were using the old edition pre-algebra book, I don't know if you talked about negative exponents last year. Did you? Okay. And then Dylan, did you learn this previously? Negative exponents? Write that statement in your notes. Negative exponent means reciprocal. So that literally, a to the negative first means the reciprocal of a to the first, or the reciprocal of a. This means the reciprocal of x to the 4th, or 1 over x to the 4th. So then, write this down. If I had m to the negative 3rd, what does this literally mean, class?
1 over
The reciprocal of
1
over
m cubed, which would be 1 over m cubed. Reciprocal of whatever is with the negative exponent thing. So if I had n to the negative 2nd, this literally means, class,
1 over
1
n.
over n.
that's how I write it, but it literally means the reciprocal of n squared, right? Or
1 over n squared.
1 over n squared, right? If I had 1 over x to the negative 5th, this literally means the reciprocal of 1 over x to the 5th. which would be what?
X to the negative fifth.
X to the
Oh, the fifth.
negative means
Negative, all the negative exponent means, now listen carefully, listen and watch. The reciprocal of 1 over x to the fifth. So what is the reciprocal of 1 over x to the fifth? That's just x to the fifth. That's all the negative means. It means take the reciprocal of this. Now, practically speaking, let's make it even easier, okay? M to the negative third could be written as m to the negative third over 1, right? Anything could be written over 1. N to the negative second could be written as n to the negative second over 1. X to the fifth could be written as x to the fifth over 1. So in other words, if you have a negative exponent in the numerator, move it to the denominator. In the numerator, move it to the denominator. In the denominator, move it to the numerator. So you could also think, practically speaking, and this is what I've taught my classes in the past, or code, negative exponent means move it to where it ain't. If it's in the bottom, move it to the top. If it's in the top, move it to the bottom. Move it where it ain't. Okay? If you want to be real Southern. I don't do Southern too good, do I? I try.
No.
Okay? But I'm not from here, okay? But yeah, just move it where it ain't. So then, write this down. If I had a 2x to the negative first, yz cubed. Here, the only thing I am taking the reciprocal of, class, is the
X to the
x.
Yeah.
Everything else has a positive exponent. So the only thing I need a reciprocal of is the x. And technically, class, this could all be considered to be over 1. So in other words, everything's in the numerator right now, correct? So if I have a negative exponent, to take its reciprocal, I need to move it where it ain't. So what needs to move? The x to the negative first needs to move to the bottom. And when it moves down, it becomes x to the first. Because I've done what the negative exponent said to do, right? I don't keep the negative there. The negative was an instruction to me. It was a command. Move it. All right? And so I moved it. Command is null and void. And so I'm left with still a 2 in the top, still a y in the top, still a z cubed in the top, but now the x is in the denominator. Does that make sense? All right, write this next one down if you would, please. 5b to the negative second over a cubed c to the negative first. Here there are two things that have to move it. I need to take the reciprocals of two things. What two things do I need to take the reciprocals of, class?
B negative 2 and C negative 1.
Well, technically one could say we take the reciprocals of b squared and c to the first, because the negative is the reciprocal word already. So since I already said reciprocal, we don't need to say the negative. Anyway, so that means I need to move what to the bottom?
The B squared.
B squared, right? It's going to come down, it's going to become a b squared. And I also need to move the
C
to the first to the top. And there's my answer. 5c to the first over a cubed b squared. Again, once you move it, the negative falls off because you've done what it said. Kind of like, for instance, if I said, what is 3 plus 2, class?
5.
Not 5 plus 2? No. I did what the plus 2 said to do, so I don't need to keep it anymore, right? That would be silly. Well, similar, the negative is an instruction, just like plus 2 is an instruction. Once you do it, you're done with it. I'm done with the negative because I did what it said to do. Does that make sense? Or, for instance, what's the square root of 9? 3. Not the square root of 3. No, just 3. The square root was an instruction. I did what it said to do, so I don't need to keep it anymore. Make sense? That kind of idea. Or, 7 squared is 49. Not 49 squared, right? I've done what the square said to do. Just drop it off. We don't need it anymore, right? That's the same kind of thing with the negative exponent. But a lot of years, students struggle with that. Like, don't I need the negative? What happened to the negative? It's gone. I did what it said to do. What about this? 2 over x to the negative third. Well, here, what do I need to take the reciprocal of?
3.
2 over x cubed. So the reciprocal of 2 over x would be x over 2, and now I will cube. Does that make sense? The negative says reciprocal. There's the reciprocal. I'm done with it, and now I'll cube to get, what's x cubed?
3x.
X cubed.
And what's 2 cubed?
8.
All right, questions on that one? All right, let me have you do several of these on your own now. All right, feel like we got a good handle on it? Anyone say, can you show one more? Or we feel like we got it? How many say, I need one more? How many say, I got this? How many say, I'm not awake? All right. If you weren't awake, you wouldn't raise your hand anyway. So it's like, let's take attendance. If anyone's absent, would you please say so? All right, everyone's here. That's good. All right. At your seats.
I'm absent.
Mine did. All right. All right, at your seats, go and work these three problems. Simplify so they don't have those annoying negative exponents. That just, don't like negative exponents. Let's get rid of them. You know why I hate negative exponents? Because they lead to fractions, and I hate fractions. See, I'm consistent. I thought you hated fractions. I do, and negative exponents are kind of right in there with them. I hate everything that has to do with fractions. Yes, sir.
I was doing first.
Good job, Adam. Your journey to the dark side is complete. Pretty good. Not really, I made that up. It makes for a great storyline.
If you were, I would be.
Alright, numero uno. How did you rewrite it, thou who weren't done first? Senor Adam.
4x squared over y cubed z.
Good. The y cubed and the z moved down and we're done. That easy. That easy. That easy. Alright, looking at the next one. Dylan, what did you get?
A squared over 2 cubed b cubed.
Good, and I'd say one more step. If you can simplify, do so. Like, you can't simplify x squared without knowing what x is. Or y cubed, or b cubed, or a squared, but we can simplify 2 cubed. 8. So we could finally leave it as a squared over 8 b cubed. But you got the main step I was looking for there. Does that make sense, though? If you can simplify, let's go ahead and do it. What about on the next one, Joshua?
6 over r squared.
Good. Sometimes students make the mistake of thinking that all of it is to the negative second, but remember the 6 is to the first. Don't move the 6, only the r squared moves down to the denominator. How many had that answer for the last one? Let me give you a few more of these. Write this one down. Or just simplify. I guess you don't have to copy it. Three more. It's like, I messed up, but it's fine.
It's just a little slap.
Yeah, how would you like it if a surgeon said that? Oh, I messed up, but it's okay. You're gonna be fine. Your nose is on the side of your face now, but people look at you a little funny, but won't be able to smell real good. I get in the way, but
That'd be a little creepy.
Yeah, it would be strange, wouldn't it?
Sue the surgeon.
Or if I did that on your test, hey, I messed up on the grading, but it's okay.
No.
37, no big deal. It's supposed to be a 73, but
Oh,
that's rough too. All right, Lana, what do we get on the first one?
C cubed over b d cubed.
Good. What about on the second one, Adam?
A y over 4x.
Good. The y moves up. The 2 squared moves down, but I like that we simplified it to a 4x. Very good. And what about the last one, Dylan?
5 over x cubed.
5 over x cubed. Questions on that?
Oh.
Question?
No, I got it.
Good. Initial step, you leave the a where it is, you leave the x where it is, because those are positive exponents. The y moves up and becomes y. The 2 moves down as a 2 squared, but then 2 squared becomes 4. All right, how about this one? Negative 4 to the negative second power. Write this down if you would. Here, some students fall into the trap of saying, ooh, negative and negative, they have nothing to do with each other. This right here means greater than 0 or less than 0. In this case, obviously less than 0. All a negative exponent means, class, is reciprocal. I want to take the reciprocal of
4, 2.
negative 4 squared. The reciprocal of negative 4 squared. What is negative 4 squared?
4 squared.
Negative 16.
Ooh. Well, 4
Negative
squared is
positive
16, so it's positive 16. Remember, this means negative 4 times negative 4, which is positive 16. Okay? Or negative to even power positive. How about this one? 6 to the negative third. What does this literally mean, class?
Reciprocal of 6 cubed.
Reciprocal of 6 cubed, or 1 over 6 cubed. And what is that? Find it real quick.
216.
108.
Good. 1 over 216. So
Oh.
1 216th.
I did that wrong.
How about this? 8 to the negative second. What does that literally mean?
Oh,
Reciprocal of 8
squared.
Reciprocal of 8 squared, which is
64. 1 over 60.
1/64, right? What about negative 3 to the negative fourth? What does this literally mean?
Reciprocal of negative 3. 4.
Well, careful. What is being raised to the negative fourth power, class?
A negative 3.
No,
Wait.
just a 3, not the
Oh,
negative.
yeah.
So this is negative reciprocal of 3 to the fourth. Does that make sense? The negative's out front. And what is 3 to the fourth?
81.
81. So negative 1 over 81. Make it sense? Write this one down. Negative 2 to the negative fifth. What does this literally mean?
Reciprocal of 2 to the
2
negative 5.
to the fifth.
No, negative 2 to the
Reciprocal.
Reciprocal of negative 2 to the fifth. And what is negative 2 to the fifth?
1 over 25.
Ooh.
Like, no, negative 25.
2,
Negative 25, isn't it?
2,
32.
32.
Oh.
But it's negative times negative times negative times 7. It's
Right.
5 negatives, so 1 over negative 32.
That was my fault. I did it.
You're doing 5 squared. 2
I
to the
was doing
fifth. 5
backwards.
2s, not 2 5s.
I was doing
How
backwards.
about this one? 2/3 to the negative fourth. What does this literally mean?
Reciprocal of 2/3.
The reciprocal of 2/3 to the fourth, which would be what?
1 over 3.
3 halves
2
to the fourth.
fourth.
Right? Because the reciprocal of 2/3, just 3 halves to the fourth. Do it very quickly. I'll let you go in just a second.
81.
81 to the 16.
Over 16. 81
Oh, right.
over 16. One more. Negative a half to the negative sixth. What does this literally mean?
Reciprocal of 1/2 to the 6.
Reciprocal of
Negative
negative a half to the sixth. So what's the reciprocal of negative a half?
2 over
2.
Negative 2 to the sixth. You see that? We took the reciprocal. We're going to raise it to the sixth to get
64.
64, positive 64. And there'd be our answer. You're going to practice with some of those in your homework this evening. For homework, page 202. For homework, page 202. Do the practice, 32 to 39. Page 202, do the practice, 32 to 39. Practicing with negative exponents. Also do the review, 16 and 18. Page 202, practice 32 to 39 and review 16 and 18. And then on page 204, do the review 5 through 8, 11, 13 through 16. 5 through 8, comma, 11, comma, 13 through 16. One more time, page 202, the practice 32 to 39 and the review 16 and 18. On page 204, do the review 5 through 8, 11, 13 through 16. We'll take a look at all of this in our next lesson. Have a wonderful rest of your day. You are dismissed.